In 11.6a, we're learning about confidence intervals. And then in 11.6b, we'll do hypothesis testing. So this kind of builds off of 11.5, where we learned the empirical rule. So the empirical rule states that about 68% of the data, assuming it's a normal model, will be within 1 standard deviation away. And then 95% of the data will be within 2 standard deviations. And then 99.7% of the data will be within 3 standard deviations. Now, those are actually estimates. A more precise amount of standard deviations for 95% is actually 1.96 standard deviations. And in 11.5, you learn that a z-score just tells you how many standard deviations something is away from the mean. So that's why it says z value at the top. All right, so here is how you build a confidence interval. All right, so there's an example above. You can read that on your own. So for numbers 1, 2, and 3, we want to build 99% confidence intervals. So we want to use this value. But I want to show you how to get that z value, just in case you forget. So I don't want you to be dependent on memorizing those 3 values. So the way you get, I'll just do the 2.576. The way you get that, so I'm going to draw a picture for you guys. If you imagine 99% in the middle, now I'm going to change that to a decimal, 0.99 in the middle. So if 99% is in the middle, that means there's 1% that is not in the middle. 1% is 0.01. And if there's 0.01 that's on the left tail and the right tail, because it's symmetric, half of 0.01 is 0.005. All right, so what that means is there is 0.005 of the data is below this value, whatever that z is, we're about to find out. All right, so what you can do is go to second vars on your calculator and go to where it says inverse norm. So normal CDF is used to find the area under the curve, either to the left or to the right or in between some z values. If you already know the area and you want the z value, you use inverse norm. All right, so there's 2 ways you can do this. You can ask it for the z value. Now, when you go to inverse norm, the first thing they ask you is for area. So you could ask it for the z value that has 0.005 to the left of it. And then you put 0 for the mean and 1 for the standard deviation. So if you do this, you basically get the 2.576 but negative. And because we're below the mean would be right here. Because we're below the mean, it's obviously going to have a negative z value. Now, if I wanted the positive z value, I would have had to tell the calculator this area. That location has 0.995 of the data to the left of it. So again, inverse norm, when you do area, you have to tell it the area to the left. So if you had changed this value to 0.995, it would have given you the positive 2.576. All right, so what does that tell us? That tells us that if we want 99% of the data in our interval, we need to start at the mean and go left and right 2.576 standard deviations. All right, so let me say that again, but in context to number 1. So if you want a 99% confidence interval, you start at the mean So we use the mean from a sample called x bar. And we just found that we want to go 2.576 standard deviations. All right, so if I want to go 2.576 standard deviations up and down, then I want to take my 2.576 and multiply it by the standard deviation. However, when you know the sample size, you take the standard deviation and you divide by the square root of that. All right, so you don't actually have to multiply this out by hand. You can if you want to, but what I think is an easier way is on your calculator, go to Stat, then scroll over to Tests, and then option number 7 says Z interval. All right, and then the first line, they ask you, do you have data or do you have stats? You want to click on stats because they told us the mean and the standard deviation and the sample size. Those are stats. Data would be if they just gave us a long list of the numbers, which is the data. So go to stats, and then where it says lowercase sigma, put in 9.2. X bar is obviously 78, N is 150. For sea level, put 0.99. You cannot put 99. It'll give you an error because it wants a number between 0 and 1. So for sea level, put 0.99. And then they give you the confidence interval. Confidence interval will be 76.065 up to 79.935. All right, so the calculator calculates the interval for you, but I want you to show the work that I showed on the first line. All right, so number 2, pretty much the same thing. So show your work. You want to start at the mean. Then you're going to go up and down, and since it's still a 99% confidence interval, we're still going to go up and down 2.576 standard deviations. All right, and then we have to multiply by the standard deviation. So that is 3.6 divided by, now the standard deviation changes based on your sample size. The bigger your sample, well, whenever you increase the denominator, it makes the standard deviation smaller. And that's because the more people or items that you sample, the more accurate you can expect to be. That's why you would have a less narrow confidence interval. All right, so again, you don't have to multiply this out. Go to Stat, Tests. Option number 7 is Z interval. Instead of data, go to Stats and hit Enter. All right, sigma is 3.6. X bar is 19.3. N is 250. Sea level is still 0.99. All right, and we get 18.714 to 19.886. All right, so for number 3, we start at the mean. We're going to go up and down 2.576 standard deviations. Multiply that by 1.5 over a radical 450. All right, so go into the calculator, Stat, Tests, option number 7. Choose stats instead of data. Sigma is 1.5. X bar is 7.2. N is 450. Sea level is 0.99. Hit calculate. And your interval will be from 7.0179 to to 7.3821. Right, so why is that interval so narrow? Well, a couple reasons. One, a really big sample size, and two, a pretty small standard deviation. On the back, we're doing a couple 95% confidence intervals first. So now the table on the front says what the z is for 95%. Let me show you again how to get that if you don't have it memorized. So draw a little bell curve. If there's 95% in the middle or 0.95, that means there's 5% on the two outsides. Half of 5% is 2.5%, but we want that as a decimal, so 2.5% is 0.025. So I have two options. I can go to inverse norm. Inverse norm is under second vars, and I could either tell it, find me the z that has 0.025 to the left of it. All right, I'm going to try the other side this time. Or I could tell the calculator to find me the z that has 0.975 of the data to the left of it. And then the mean is 0 because we want a z value. And z values have a standard deviation of 1. All right, so if you do this, you get 1.96. All right, so as we've been doing, we start at the mean, we go up and down, and now we're going up and down 1.96 standard deviations. If we want to go 1.96 standard deviations, then we have to multiply 1.96 by the standard deviation divided by radical n. So 3 is the standard deviation for the whole population. 3 divided by radical 10,000, that's the standard deviation if we were looking at a bunch of groups of size 10,000. All right, so this is going to equal, if we go to our calculator, stat test option 7, sigma, put 3, x bar is 21, and is 10,000, put 0.95 for the sea level. All right, so a very narrow interval because our sample size was so big, 20.941 up to 21.059. All right, number 5, start at the mean, up and down, 1.96 standard deviations, 3.5, that's the standard deviation if we were doing groups of 1. We're doing groups of 7. So imagine if I had everyone put their height on a number line. So imagine how spread out that data would be. And imagine if I put everyone in groups of 7 and I said, okay, now put your group's average height on a number line. That would be less spread out because now the tall people and the short people, their heights would be averaged out with 6 other people. So that kind of explains why you divide by rad 7 when you're doing samples of size 7. All right, so again, we go to stat, test, option 7. Sigma is 3.5. X bar is 58. N is 7. Sea level 0.95. Answer is 55.407 up to 60.593. All right, and now we're doing a 90% confidence interval. All right, so I'll draw a picture up here. 90% in the middle. Means that you have 10% left over, which means 0.05 and 0.05. All right, so if I do inverse norm, right, I'll go back to doing this side. That has 0.05 to the left of it, a mean of 0, a standard deviation of 1. All right, you get negative 1.645. Doesn't really matter that it's negative because it's going to go next to a plus or minus anyway. All right, so we have to figure out what everything is based on this paragraph. We start at the mean. All right, so they say average of 1.8 hours. We're going to go up and down 1.645 standard deviations. Standard deviation is 0.6. We have to divide that by our sample size. We're going to do a sample of 388. All right, going into the calculator, stat, tests. Option 7, sigma is 0.6, x bar is 1.8, n is 388, C level is 0.9. Calculate, you get 1.7499 up to 1.8501. Right, so another reason I like going to the calculator instead of multiplying this out by hand. This is a rounded value over here. 1.645 was rounded to 3 decimal places. But if you go to stat, test, z interval, they don't round that value. They use the whole thing, and then they round the finished product. All right, one more. All right, so we're going to use the 2.576 that we were using on the front. I won't bother finding that again using inverse norm. All right, so let's scan the information for everything we need. All right, so average was 1.6. We're going to go up and down 2.576 standard deviations because it's a 99% confidence interval. Standard deviation is 0.5. That gets divided by the square root of how big our sample is. Go to stat test, option 7. Sigma is 0.5. X bar is 1.6. N is 233. C level is 0.99. Calculate. Your interval goes from 1.5156 up to 1.6844. All right, and that is all for 11.6a.